So we all know what exponents are, right? What is an exponent? If you had to describe to, let's say, your friend or someone younger than you. So we have exponents, and these are used when? Why do we need this in life? What would you tell that to that younger person? In your great wisdom. No great wisdom. Okay, what are they? What are they? Yes. They are shorthand to write repetitive multiplication, right? So instead of writing 2 times 2 times 2 times like 100 times, you just write 2 to the power of 100. They're shorthand of writing repetition of multiplication, right? So do we need exponents in real life?
Yeah.
Can you give me an example?
Scientific notation.
Okay. No, when I say real life, I mean like real life, not in school. School is to prepare for real life. So that's actually good. The name of what you just said, scientific notation, it pretty much explains when you need it, right? In science, when you're studying science, anything related to science, such as studying the number of bacteria in a cup, right? Number of animals in a forest. What else? Number of atoms, water molecules in a beaker of water. So if you guys study chemistry, things like that, these numbers are enormous, right? Enormous. That's why you need these notations. Also, you kind of need it when you are studying money. So if you're something financial related, and you're helping the Bank of Canada do some calculation and interest, you probably need exponents too, right? So it pretty much sounds like you need it if you're gonna do anything like advanced, which makes you a lot of money. Okay, so that's a brief explanation why you need exponents. Absolutely necessary you know how to get a handle on big numbers. So the first law, right? Very simple law. If you have same base and you have different exponents, you can add exponents. What is that in plain everyday English? So instead of telling somebody that's the rule, like what is that? Actually, you can actually explain it. Okay, if that's hard, how about like this? You can add these two. Why?
There's 3 2s and 5 2s.
Right, because there's 3 2's multiplied together here, and because there's 5 2's multiplied together here, in total we have 8 2's multiplied together as a whole. It's pretty logical, no? The first law is so easy and so obvious if you think about it. Okay? The second one. Okay, who can explain that one now? That's a little bit more complicated to explain. If you can say it, like put it in your own words, you probably never forget these laws. If you memorize like a picture, boom, it's like a snapshot, then later on you're like, uh-oh, I don't know what that was for, so you forget it. What's the second law for? Again, let's do it with number, okay? Why is this same thing as 5 minus 3? Yes.
Because 2 is multiplied 5 times as a numerator and denominators.
3, yeah.
Multiplied 3 times, so you can just. It's like if you have a repetitive multiplication like 2 times 2 times 2 times whatever, you can just divide and then get rid of it.
Okay, so the top, you can break it down like this, can't you? Whatever is same up top and bottom, that'll divide out to give you 1. How much of it is exactly the same? Well, whatever is matching the lower exponent, right? So this is exactly, the 3 will be taken away from the 5, so it's 5 minus 3. Okay, now that's nice when the numerator is bigger. What about if the numerator is smaller, like this? If you follow the same law, you get this, 3 minus 5, which is 2 to the power of negative 2. What does that mean? It's what? It's a fraction. What is it exactly? 1 over 2 to the power of 2. You guys remember this? Okay. And you can see that must be the case. Look, if we do the same thing from the bottom like this. Okay, so those two must be the same. In general, because of the second law, right, 2 to the power, or sorry, anything to the power of negative exponent must be 1 over the power of the positive exponent. Okay, that's very important. Okay, what's anything to the power of 0? 1. Why? Because?
Well,
I think it had some
it starts from 1 and then it keeps going on. Like the factors, the number of factors, like if you have 2 to the power of 1, it would be just 2 and then you just keep going on.
Okay, so actually the main reason why
Isn't it like if it's like a over 5 over a over 5, then it's like they're both like it's the same number divided by each other, so it's 1.
yes, I don't know if you guys got that. Okay, so what Noah said, isn't it that if you have a over 5 and then you have over a over 5, that means it's the same thing, so isn't that 1? I don't know, I'm just really like coding him right now. Does that make sense?
So if it's a over 5
Yeah.
and it's over a over 5, then you're subtracting 5 minus 5, so
Right.
it's 0, and you have the 2 like the same numerator and denominator, so it's 1.
Right, so the reason why it's equal to 1 is because like mathematics, right, or logical rules, they cannot contradict each other. So the reason why this is equal to 1 is actually because we have to follow the first and second law. Okay, and anything to the power of 0 means the following: same number minus the same number. Any two same numbers subtracted with each other will give you, but that actually means in division this. Same thing divided by the same thing. What's same thing divided by the same thing? It doesn't have to be 5. It can be whatever number you want. It's 1 always. Okay, so that's why it's 1. Make sense?